In this video, I want to give you a brief introduction to multiplying polynomials. And so the bottom line is multiplying polynomials essentially is just a series of distributions. So I'm going to go ahead and start with one that's a classic distributive property problem. So we have this negative 7x cubed, and this is a monomial, and we're going to multiply this monomial by this trinomial. And it looks exactly like the distributive property, and that's exactly what we're going to do. I'm going to take that negative 7x cubed, and I'm going to distribute him across all three of these terms in this polynomial, and I'll multiply it in each case, and then go ahead and write my product. So remember, when I'm multiplying these terms, I'm going to multiply the coefficients. So negative 7 times 5 is negative 35. And then when I multiply these variables, they have the same base, so x and x. So when I multiply variables with the same bases, I will be adding their exponents. So x cubed times x squared, like bases, so 3 plus 2 is 5. So that first distribution will give me a negative 35, x to the fifth. All right, so the next distribution, I'm going to take this negative 7x cubed and multiply him by negative 2x. So the coefficients first, negative 7 times negative 2 is a positive 14. And x cubed times x, remember this x has an exponent of 1 when it's not explicitly written. So I'm multiplying like bases, they both have x. I'll add these exponents. So 3 plus 1 will be x to the fourth. And finally, this is a constant here, this positive 6. So I'm just going to multiply the negative 7 times the positive 6 to get negative 42. The 6 does not have any variables, so the x cubed will just come along for the ride. So here is the product then when I multiply this monomial by this polynomial, or in fact a trinomial, 3 terms here. And what I did was I just focused on distributing. So we'll see that that idea of distribution will continue. In this second example, you'll see I'm going to multiply two binomials together. This first binomial is 2x minus 5, and I'm going to multiply that by the binomial x plus 4. So as promised, this is just going to be a series of distributions. So I'm going to start with this first binomial, this 2x minus 5, and I'm going to go term by term. So the 2x I need to distribute across the x plus 4. And then once I've done that, I can move on to the next term. This negative 5 needs to be distributed across the x plus 4 as well. So ultimately what you'll see happening, and I think maybe when we start using polynomials with more than 2 terms, it will be a little more obvious. But every single term in this has to be multiplied by every single term in this. So this 2x gets multiplied by both of these through this distribution, and then we move on to the negative 5, and he gets multiplied by both of these through that distribution. Okay, so after we do all those multiplications, then we will need to combine any like terms. So 2x times x will be 2x squared, and 2x times positive 4 will be positive 8x. Okay, so then we move on to our negative 5. So negative 5 times x is minus 5x. And a negative 5 times a positive 4 is a negative 20. And you'll see this is nice because these middle two terms are like terms. So let's go ahead and combine them. So I'll write the 2x squared there. He just comes along for the ride. And we have positive 8 and a minus 5. So 8 minus 5 is 3, and he's positive 3, and that variable is x. And then, of course, the minus 20 comes along. So that's how we can do a binomial times a binomial. Here's a quick example for a binomial times a trinomial. And what I'm going to introduce now is a vertical stacking method where we keep all of our like terms in columns. And that makes it a lot easier to kind of keep track of like terms and add them at the end. So once again, I'm going to distribute every single term from this binomial across every term in this trinomial. So the 7x will be multiplied by all three of these terms. And then the negative 2 will be multiplied by all three of those terms. And then any like terms will need to be combined. So 7x first. So 7x times 4x squared. 7 times 4 is 28. And x times x squared is x cubed. Okay, 7x times negative 3x. 7 times negative 3 is negative 21, and x times x is x squared. And finally, 7x times positive 1 will just be 7x. Okay, so now we have distributed the 7x across this trinomial. So let's move on to the negative 2. So negative 2 times 4x squared. Well, the negative 2 times the 4 makes negative 8, and it's x squared. So what I'm going to do is look for the x squared term, and here it is, and I'm going to write that negative 8x squared underneath that x squared term. So in this fashion, then, we can align vertically all of our like terms. So the next one, negative 2 times negative 3x, that'll be positive 6x, and you'll notice once again I'll line these x's up. And finally, negative 2 times positive 1 is a minus 2. And what I can do is put a line under all this, because really what I'm doing is going to add or combine all of these like terms. So the 28x cubed is the only x cubed term I have, so it'll just come down to the final answer. And now we'll go column by column. So negative 21 minus 8 is negative 29x squared. And again, the terms don't change. So the x squared and the x squared stay x squared. That's our x squared column. So plus 7 and plus 6 makes a positive 13x, and that's our x column, and then minus 2. So here then is the product, and it's written in standard form, for this binomial times this trinomial. In this last example, I'm going to do a trinomial times a trinomial, and you'll notice based on these powers that not every term is present. So here I'm missing the quadratic term, and here I'm missing the linear term. So things might not line up exactly, especially as nice as they did in the previous example, but we can still line them up. So once again, 3 terms here and 3 terms here. So I'll be doing a series of distributions, and I'll ultimately have 9 terms, because every term here needs to be multiplied by every term here, so 3 by 3. So we'll start with the x cubed, and the coefficient here is 1, so really all I'm doing is adding 3 to these exponents, right there and there, and then putting the x cubed with the 3 there. So x cubed times 2x cubed will be 2x to the 6th. X cubed and minus 5x squared will be negative 5x to the 5th. Notice now we're missing this linear term. There's no x. We move right onto the constant. So x cubed times 3 is going to be 3x cubed, and that's positive. So I'm going to go ahead and leave just a little space for my x to the 4th term, which could show up in other multiplications. Okay? So the x cubed is done, so let's move on to the positive 2x. And I'm going to take this positive 2x and distribute him to all 3 of these terms there. So positive 2x times 2x cubed, well, 2 times 2 is 4, and x to the 1st, so 1 plus 3 is 4. Here is going to be this quartic term, so positive 4 x to the 4th. It's nice that I left that space in there because I filled it in with this x to the 4th term, so I can keep everything in standard form. So positive 2x times negative 5x squared, so 2 times negative 5 is negative 10, and that'll be x cubed. So negative 10x cubed, and then 2x times positive 3 will be 6x, and so once again I'm going to leave a little space for my quadratic terms, those x squareds. Okay, finally I have a negative 1 that I'll distribute through there. So negative 1, remember when I multiply by negative 1, all I'm really doing is just changing the sign. So I can take all of these terms and just put them down here, but I need to change their sign because I'm multiplying by negative 1. So this positive 2 becomes a negative 2x cubed. This negative 5x squared becomes a positive 5x squared, and you'll notice that x squared goes in my quadratic column here. And then this positive 3 becomes a negative 3, and I have all the terms written. You'll notice it seems like there's a lot of staggering here, but I have these open spaces, and that's because not every term had a coefficient other than 0. So I had this 0x here, and I had a 0x squared here. Okay, so now we're just going to add all of these polynomials together. So just bring it down, so 2x to the 6th minus 5x to the 5th plus 4x to the 4th. I put a plus right here. because it's positive, okay? And then now 3 minus 10 is negative 7, minus 2 more is negative 9x cubed. And then basically the rest of these just come on down because there are no other like terms. All right, so there's a quick little way to be multiplying a trinomial times a trinomial, or for that matter, any polynomial with more than just a few terms. And it does this really nice vertical column, vertical stacking method, right, where I align all of these like terms in columns. So remember, when you're multiplying polynomials, focus on a series of distributions.